Okay. Hello, and thank you for joining us for this. Sorry, I don't know what I'm saying here. I gotta just like. Hello, and thank you for joining us for this webcast about lessons learned on Passive House projects. My name is David Solomon. I work with Revision Architecture. We are a small design firm. We have two studios. We have a high performance architecture studio and a sustainability consulting studio. And so we design our own high performance passive house projects. And we also work with other designers and developers to help them with their projects, whether that's Passive House, Living Building Challenge, LEED, well sites. We do a ton of consulting to help others achieve their sustainability goals. Over half of us are either CPHCs, CPHDs, or FIAS raters. And we all have a bunch of other sustainability related certifications as well. So I'm not going to talk to you today about how to achieve Passive House. This is really how not to achieve Passive House, or rather, what are the common mistakes that get made during construction that can prevent you from achieving your performance goals. So whether you're working with PHI in the international system or FIAS in the US system, it doesn't really matter. The things that I'm talking about on this webcast are really relevant to both systems. And frankly, a lot of the things that I'm talking about are relevant even if you're not building a passive house. Here is a screenshot from Woofy, but again, if you're using PHPP, it doesn't matter. The point is that you work really hard to design a passive house compliant building. And you finally get that letter from either PHI saying that you've achieved design stage assurance, or you get it from FIAS saying that your project is pre-certified and that if it's built the way it's designed, it will achieve passive house. And then what can happen is that construction starts and there's RFIs and there's substitution requests. And if you don't keep on top of that, or if people start accepting substitutions before you've had a chance to actually vet the effects, there's a very real likelihood that your project could fail to meet its passive house goals. So one place where projects often fail are at the continuous insulation and air sealing boundaries. So one of the things that we recommend doing with the contractors is the pencil test. Now I know this sounds really elementary. It's one of the first things you learn in the CPHC or CPHD course, but it really is worth it to sit down with the contractor at a pre-construction meeting, pull out the trace, pull out the red pen, and explain, when you're talking about continuous, you really mean continuous. And it's really going to take some forethought and planning to ensure that that continuity actually happens in the field. Show them in section as well, and also show them at larger scales. I also find that it helps to show the contractor how the design has changed, right? So bring some older versions with you and say, like, in this case, the original plan was for the CMU stair core to penetrate the frame walls and disrupting the continuous thermal and air barrier. In the revised version, the frame walls continue along the outside of the CMU stair core, and that creates that continuous thermal barrier, and it simplifies the continuous air barrier. This could be further refined so that the CMU gets replaced with a rated frame stair core, which is fine. The point here is that you're showing the way that the design has changed in order to achieve performance goals, and you're explaining to the contractor why those changes were made. You need to increase the scale and look at the details with the contractor too. So here, that red line is representing the subslab vapor barrier that gets woven underneath the sill plate and then taped to the sheeting. Very, very common passive house detail. The blue shows all the rigid and cavity insulation. And then that lighter blue is showing a foam glass block that creates that thermal break and bearing surface for the brick water table to sit on. And this is a critical component to walk through with the contractor and explain why it's there and how it is and how you're creating that continuity. You also want to point out things to the contractor that sometimes don't make sense right now. Something like this tape that's shown underneath the subslab insulation. Something like that should be caught before the construction documents are issued. However, sometimes things slip through. And what you don't want is to have the contractor find something like that and then start to disregard other pieces of more vital information that they're seeing in the drawings because they just think, oh, those architects, they don't know what they're talking about. Well, that tape is actually, although it's impossible to put in that location, you do want to tape the seams of the rigid insulation under the slab. And so explaining the design intent is extremely important, even if a detail like this somehow slips through, let the contractor know the reasoning behind it. Here's another detail that would be really important to walk through with the contractor because it really gets into the issue of sequencing and the responsibility of different trades. Sometimes some trades will be responsible for one part of the air barrier and another trade will be responsible for a different part. And if the sequencing isn't thought through enough, then it would be very possible to essentially miss an area. An area doesn't get insulated or an area is not able to get air sealed properly because it was covered up too soon. So here we're showing the zip sheathing going on, and then the joints get taped, and then the roof insulation is installed, and then the roof membrane gets applied, and then the exterior wall insulation is attached, and then there's spray foam in the cavity that fills in the gap left between the outside of the sheathing and the roof insulation. And then finally, the bat insulation at the rim. Now, this the actual sequence might be different on your project. That's fine. The point is, have the conversation with the contractor. And I know for architects, this gets a little bit sensitive because we typically don't talk about sequencing. We don't get into means and methods with contractors. So, you're not telling the contractor, what to do or how to do it. But it is important that you're having that conversation with them so that they're coming up with a plan. They understand the reason for it and they own it. So just remember, the sum is greater than the parts when it comes to a passive house assembly. If you get some of the insulation but not all, you're not going to pass. If you get some of the air barrier but not all, again, you're not going to pass. And sometimes, despite talking with the contractor, things can go wrong. So in this case, on the left-hand side, you see some metal reinforcement, some subslab vapor barrier. It's all waiting there in anticipation of the concrete masons. And you'll notice that edge of the vapor barrier actually seems a little short. And that's because the masons showed up on the site and they said, what's all this extra vapor barrier doing there? We don't need that. And so they cut it all off, right? The masons didn't understand the design intent, and all they were thinking about was their limited scope of pouring a slab, and this extra plastic was in their way. So we were able to fix it they used Prosoco. They painted a few inches down onto the slab and up over the sill and a few feet up the inside of the wall sheathing. And that did fix the problem, but it was expensive and it was time consuming. So when you're having a conversation with the contractor about air barriers, it's also really worthwhile to give them visual examples of, what kind of quality do you expect? What's a good tape job on a zip system versus what's a bad tape job? I will tell you this, I used to think that a good tape job costs just the same as a bad tape job. But the truth is actually that a good tape job is a lot cheaper than a bad tape job. Here on this sheathing example, you see huge gaps in the zip sheathing, right? That's potentially going to take more tape. We've got tape starting to peel off and lose its adhesive strength, right? So that's going to need to get cut. There's going to be wasted tape, or it's going to get taped over and there'll be bubbles and potential air leakage. Here on the lower right-hand side, the arrow is pointing at holes that have been torn into the subslab vapor barrier because this barrier was never taped to the sheathing when it was supposed to have been. Here, that middle arrow on the right-hand side, that's pointing at where the subslab vapor barrier has just been cut too short. And so they'll probably need to use Prosoco or something else to maintain that continuity. So again, the subslab vapor barrier, it should have been taped to the sheathing immediately after the walls went up. But for some reason it wasn't. You can see on the right-hand side how it's getting covered with dirt and walked on. And another thing to keep in mind too is that the brown zip sheathing is actually not rated as an air barrier. Only the green zip sheathing is rated as an air barrier. I have seen brown used successfully as an air barrier in a sealing condition. But buyer beware, just keep in mind that if you intend on using zip sheathing as an air barrier, make sure you're buying the green sheathing that actually carries that rating from Huber. Another thing that designers need to think about, and that is really important to communicate to the trades in the field, is things like plumbing vent stacks, right? We typically don't ever think about them at all. I mean, maybe we begrudgingly leave a little bit of room for a chase, but typically, we don't give a lot of thought to how they design other than how they might stack in a multifamily building. But in a passive house project, you need to have room for the gaskets and for the tape where they penetrate, where things like plumbing stacks penetrate the air barrier. And so, build it into the design early, make sure you have the room, communicate it to the subs. And they also might be unfamiliar with these types of gaskets and tapes. This might be their first passive house project. It's not rocket science to install. They can figure it out pretty easily, but make sure they understand it and make sure that these products are referenced in the MEP specs and on the MEP drawings, not just the architecturals. Here's a couple other applications with refrigerant line and electrical penetration. And then finally, when it comes time to do the blower door test, here are my colleagues, Angela and Nick, on the left-hand side setting up a blower door test. And on the right-hand side is Nick teaching our contractor how to use the thermal imaging camera. In the middle, you see an image from the thermal imaging camera, and there's an area on the left-hand side of that photo that shows where there's no insulation. And you can see the thermal energy bleeding through. And then on the right-hand side of that, where the purple is a bit more wispy, that's indicative of an air leakage. And so what we do is we teach the contractors how to use the thermal imaging camera, and we often loan it to them. And it really becomes like a game. And once they understand how to use the camera and how to interpret the imagery, they can use it to get instant feedback on their work. You know, they can use it to find the leaks, find the thermal bridges, correct them, and again, get instant feedback. And we found this to be really empowering and engaging to do this with the contractors, and it becomes something that they like to do. And we've had a lot of success with this tactic. So in terms of best practices, right, prominently post airtight building signs all over your project. I've had people say that this doesn't work. You know, obviously results will vary, but I would encourage you to do it anyway, because what you don't want to do is put yourself in a position where someone says, oh, I didn't know, right? So along those lines, also assign one person responsibility for maintaining the air barrier. It's often the site supervisor. And make sure that you discuss the importance of the air barrier with all critical subs prior to commencement of their work. So just to recap, make sure the contractor understands the design intent. Use RFIs, right? No cowboys. We don't want the contractors to just make things up in the field. If they have a question, make sure that they're going to ask it. Photo documentation of assemblies is critical to achieving Passive House certification. So along with making sure that someone is responsible for the air barrier, make sure someone is also responsible for documenting the assemblies before they get covered up, right? Make sure that subslab insulation is documented. Each layer of it is documented before it gets covered with concrete, and it'll never be seen again. So if you're doing FIAS, coordinate with the FIAS rater, and if you're using the international system, then make sure someone else is responsible for that documentation. So one of the critical components to the thermal and thermal barrier and the air barrier is, of course, the windows and doors. So you also want to let the contractor, so again, this is a place to know that you know when to take a red pen and a lot of show how this windows and doors are part of those potentially seen extreme thermal air contractor on the contractor. Passive House project, show them examples of the materials. So one of the things that I like to point out is things like when we intentionally don't use, they will wonder why they can't just use a nailing flange. So in this case, for the study by Quantum Fronters entry doors, showing how we use Conair 451T thermal frame high value changes are not as good in terms of outside their thermal performance, by your sheathing, air sealing capacity inboard as a passive house door would. Right? But and so they can be outfitted. This is helpful to explain to the contractors that ADA thresholds. You're not just trying, and that's something that is often hard to find. You're not just trying to do things in the most complicated, at least for a reasonable amount of money. There's a sound, and so we use these for the Conair 451Ts, and it has a tremendous effect. You have to do a little bit of extra weather stripping, but they're affordable. Here is they're effective tape job, and they're executable. Is about to go horribly wrong. Those are the three. Right. Again, communicate the three keys that we always talk about with contractors standard that you expect to the contractor. Passive house projects. We want our details to be affordable, executable, and effective. We're not trying to make their lives harder, and we're always open to talking with them about how these details could be better. How can we make them more affordable, more executable, and more effective? Using these doors is one way that we found to do that. So let's talk a little bit about substitutions. Most often I've found that the things that the contractors want to substitute are the systems. And it's not really going to be the, typically it's not really how the systems, how the systems are installed as it's more of a what is installed, right? So in this example, this is an electric fire pump, and the fire pump will hopefully never go on. If it does, you honestly have more problems than just how much electricity it's using. However, if a contractor wants to substitute an electric fire pump for a diesel fire pump, you could wind up blowing your energy budget. And the reason for that is that a diesel fire pump, the engine needs to be kept warm all the time. So it has a block heater, an electric resistance block heater, and that keeps that, that engine warm so that the diesel motor can turn on instantly if it's needed. And that just uses a lot of energy, a lot of constant energy. And if you haven't factored that into your primary energy calculations, then you could very easily blow your budget. Another place where I often see a lot of substitution requests is in the heating and cooling system, whether it's a mini split or a VRF. There's lots of different companies that make this equipment. I'm not endorsing any of them. But one of the problems that, frankly, with Passive House sometimes is that the loads are so small that it's difficult to get appropriately sized equipment. You know, the loads are so low that it's difficult to find equipment that's small enough. And so you run the danger of equipment short cycling, as is being shown in this diagram here. And so what that means is, so short cycling happens when equipment is oversized, and that's going to lead to more maintenance of the equipment, shorter lifespan of the equipment, and less comfortable interiors for the occupants of the building. So if you are going to entertain substitution requests for a VRF or a mini split, any kind of heat pump, you know, make sure that you know, the cost difference is good. Make sure that the efficiency is good, and most importantly, make sure that the size of the equipment is actually appropriate to the loads of the building. Another place where you really have to dig deep and interrogate the options, right, is something like a VRF. So in this case, I'm sorry, not a VRF, an ERV. So in this case, we're showing a centralized ERV. And the contractor wanted to change it for a different centralized ERV. Okay. And we have to ask, does the proposed substitution, does it have an AHRI rating? Or has it been certified by either FIAS or the International Passive House Institute? Because if it doesn't have an AHRI rating, or it hasn't been Passive House certified, we're going to have to derate the performance of that piece of equipment by 12% as a safety factor. We can't just take the manufacturer's word for how efficient their product is. And so this derating is likely to, you know, blow one, if not more, of your performance targets. But let's just say that the piece of equipment does have an AHRI certificate. So we say, okay, great. We can accept the performance as stated. However, it's a little bit less efficient than the original model that was spec'd. So, and we're going to need some additional PV on site. Can that additional PV fit on the roof? You do the analysis, fantastic, you can fit the PV on the roof. But how much more is that extra PV going to cost? Well, the proposed substitution for the ERV costs $20,000 less than the original specified equipment. However, the additional PV costs $70,000 more. So that makes the project $50,000 over budget. Now, if your architect has gotten ahead of you and accepted that substitution without you vetting it first, you're likely to have a very angry owner. You're also likely to have a very sad architect and a very happy builder. Right? In order to do that due diligence, the architect probably has a fixed CA fee. As a consultant, you may be hourly. But basically what happens is that the project and the architect end up subsidizing the builder. So make sure that you vet any proposed substitution very closely. Make sure that you dig down and really understand the various layers of ramifications. And keep if you're a consultant, keep your architect on a short leash. There'll be a lot of pressure to make decisions faster in construction, but they can really blow up in your face. Sometimes it's not always the architect that gets ahead of themselves. Sometimes it's the builder. In this case, in the photograph on the left, you can see a little bit of the green zip sheathing still left on the rim joist and a little bit by the window. And what happened was that the builder didn't carefully read the specs or the drawings, which said to use plywood and Vapro Shield for the air and weather barrier. And it said they use zip. The client was not the forgiving type and forced them to rip the sheathing off and replace it with what was designed. If they had followed the submittal process like they were supposed to, this wouldn't have happened. Right? They would have been able to save a lot of time and money and aggravation, and as well as a lot of political capital. There was a lot of goodwill lost with the client over that. Frankly, you know, as architects, it's something that we would have let go, but the client in this case, you know, again, and I'm not. It's not to say that they were wrong. You know, I always tell the builders, you know, when they're resistant to the submittal process, like, look, this is for your protection too. It's not just for us. It's not just for the building. Give us the submittals, and it will save you a lot of pain at some point in the project. It always does. So another example of that, where the builder got a little bit ahead of themselves, different project. Here, this is a light deck insulated formwork for concrete slabs. And there's a metal rib installed in these. It was supposed to be wood. The metal has a higher thermal bridging capacity. And, you know, they, again, didn't follow the submittal process, bought the wrong product, and then had to spend money on additional insulation in order to mitigate the thermal bridging. And again, we could have saved them a lot of time, money, and aggravation if they had just, you know, spent 10 or 15 minutes and mailed us a submittal ahead of time. Another example of the builder getting ahead of themselves. This is an ICF basement. The ICFs as drawn and specified were 1 foot, 1 1/4 inch thick. The EPS sides reach about 2 3/8 inch thick with an 8-inch core in the middle. And the builder bought the incorrect ICF that had these additional 4-inch EPS inserts. So again, we could have saved the builder tens of thousands of dollars in both material and labor costs if they had just taken 15, 20 minutes at the most and given us a submittal Um, and we would have said that the product is incorrect, and please revise and resubmit, and it would have been so worth their time. So mistakes happen, and fortunately on this project, it wasn't catastrophic. This is just a residence, and it's a fairly large residence, so we were able to absorb that loss of space without too much headache. There was a few problems that had to get worked out. But if this had been a multifamily house, that mistake by itself could have been catastrophic, right? Remember that you can have too much of a good thing. And what I mean by that is that on a multifamily house, cooling tends to be the limiting factor, right? They're internally load dominated. Heating isn't the issue, it's cooling. And so on this multifamily project, just as a little thought experiment, we increased the walls from R29 to R44, which is what we would have had with that extra 4 inches of insulation. And you can see that the cooling demand increases from 6.89 kBTU per square foot each year to 7.11 kBTU per square foot each year. And the cooling demand limit is 7.2. So a little mistake like this on a multifamily project could have absolutely disastrous consequences. Another place where you can get into trouble is specifying kilowatt hours versus kilowatts. And I think a lot of people don't understand the difference. Kilowatt hour is a unit of energy, whereas a kilowatt is a unit of power. There are lots of units of energy. Energy is just power times time. So whether it's calories, BTUs, joules, quads, etc., right? These are all just different units of energy, and there's others as well. The calories in our food, right? That's a unit of energy. A chicken Waldorf wrap, right, has 333 calories, which is equivalent to about 0.39 watt hours. That means that someday we'll be able to power our buildings with chicken Waldorf wraps, but until then, we're forced to rely on energy from the sun instead. I use PV watts. It's from the National Renewable Energy Labs to preliminary sizing of the PV systems. It's an industry standard tool. After you put in your location information, you specify the size, the power of the PV system. And then PV watts will give you an approximate range for how much energy that system can produce. So it says system output may range from 5,230 to 5,655 kilowatt hours per year near this location, right? For an average of 5,445 kilowatt hours per year. Now that assumes certain things, right? It assumes the module type, it assumes the array type, it assumes a certain systems losses, it assumes the tilt of the panels, right? And so what if we change that tilt from 20 to 0? Well, then all of a sudden that average 5,445 kilowatt hours per year drops 14% to 4,731 kilowatt hours per year. It's still a 4 kilowatt system. The power hasn't changed, only the efficiency of the system, because we've changed the tilt of the solar panels. And so that's why when you're specifying these systems, you want to specify the kilowatt hours per year. You want to specify the energy generation capacity and let the PV installer determine the size, the power of the system. If you specify kilowatt hours, if you specify kilowatts instead of kilowatt hours, you could wind up not having as much power as you actually need to meet your certification requirements. And so, as an architect, we always like to, architects like things lean, whereas we joke that the PE behind an engineer's name stands for put extra, right? They like their systems just a little bit bigger. They like their structures to be just a little bit stronger. And honestly, it makes sense, right? But a PV system is one place where I really agree. Put a little bit extra. Give yourself a buffer. Be completely transparent with your client about it. It's always easier to reduce the size of the PV system farther down the line if that amount of energy is not needed. It's much easier to reduce the size of the system rather than increase it later on. And things do change during construction, and sometimes substitutions are necessary and do need to be made. So give yourself a little bit of a buffer, with your client's buy-in, and know that you have a safety factor for things that may change during construction. So I hope that you've gotten some useful information from this webinar. And our goal is to help you and others achieve Passive House. And instead of your projects looking like this, we want them to look like this. We work hard, and we believe in these projects. We believe in you. If you have any questions or comments, please feel free to reach out and share your tips and tricks as well. All right, thank you very much. Really appreciate your time. Take care, everybody. Bye-bye.